Our project is AgriPulse AI, as you know. It is a smart crop diagnostic and IoT management hub. In modern agriculture, precision and timely action are critical to avoiding devastating crop failures. Our team has built an intelligent, unified ecosystem that bridges data-driven AI diagnostics with live field elementary. So, what to this next slide? The workflow begins at the top stream with the farmer who interacts with our system by uploading a standard image of an infected or suspected crop leaf. This image is immediately processed via our AI inference engine, which isolates features to execute precise disease detection. Once a disease is classified, our system pulls a specific prescriptive actions to form a saturated step treatment recommendation. Concurrently, the lower stream functions as a continuous IoT sensor networks embedded directly in the field. These sensors monitor real-time soil moisture, environmental temperature, and primary soil macronutrients, namely nitrogen, phosphorus, and many etc. Both streams merge seamlessly inside our uh, data hub to fuel a unified crop health monitoring interface. What took place next slide. So, sir, our future scope announcements is as a design and analysis of algorithm project, our focus is heavily directed toward optimization, execution speed, and scalability. Looking forward, our roadmap includes five main areas of improvement. First, we plan to transition from simulated telemetry to live IoT integration using dedicated Raspberry Pi or Arduino hardware deployments. Second, we aim to implement Edge using Edge AI processing by leveraging TensorFlow process detection, allowing real-time on-device disease detection directly in the browser without server round trips. Third, we will introduce a distributed cloud database structure to handle scalable storage for historical crop data over multiple seasons. Fourth, we plan to embedded weather forecasting APIs to offer proactive predictive crop planning. Lastly, we will integrate GPS precision farming to generate location tag recommendations tailored to distinct microclimate patterns. What to please next slide. So it is the website of here is soil moisture, ambient temperature, and nitrogen, etc. This is the sir, IoT nodes. Here every nodes are in here. This is traceability and this is settings. And our code works like sir, here suppose I upload a picture of a leaf. So this is the dashboard hour. There is soil moisture, ambient temperature, and the level of nitrogen in soil. And this is the IoT nodes. Every node ID here. We upload many of, and this is the traceability. And here is the settings. Sir, I will show you an example. So it is the tobacco leaf. Here is the diagnostic mesh to spot a spider mite infestation and system confidence is to 89.7%. And sir, here is the recommended countermeasures. Introduce predatory mites or apply an organic neem oil solution at dusk to minimize direct light leak scale. Here is the solution, here is the problems.
Very good. Carry on
This
this
is
work. Very good.